Welcome back to another video. Today we're going to be looking at Leetcode 74, search a 2D matrix. This problem description tells us that we're given an m by n integer matrix called matrix with the following two properties. Each row is sorted in non-decreasing order, so it's sorted in ascending order, and the first integer of each row is greater than the last integer of the previous row. And given an integer target, we want to return true if target is in matrix or false otherwise. Okay, so let's look at an example. This is one of the matrices, and we want to find our target of 3 within this matrix. So let's look at the matrix representation as a list, right? So this is it's an array, and it's basically obviously a two-dimensional array. Each element is a row. So, how would we solve this, assuming that this was not a matrix? Let's just assume this is not a two-dimensional array. Assume this is, somehow 1D, and just remove all of these brackets. How could we find, I don't know, 3, right? Well, we could do a linear search, assuming this is just a single list. We just do a linear search. We'll look at each element. Okay, boom, we found 3. Therefore, we return true because it's in our list. Okay, so that's a linear, big O of n time. But we want something slightly more optimal, right? We want a time complexity which satisfies this, this condition here. So how can we do that? We want to satisfy that time complexity. Well, another way, again, assuming this is just, for now, it's not a 2D list, it's just a 1D list. We can do binary search. So if, in this example, we would find a midpoint and then, say, is our target less than it? Yes, it is. Look again. Is it less than it? Yes, it is. Okay, we found 3. 3 is our midpoint. 3 is also our target. We return true. Otherwise, we would return false if 3 wasn't in the list. Okay, so that's our binary search. But how would we solve this with a matrix, right? I mean, there's a couple more things that we need to factor in. The fact that we can't just simply, our left and right pointers would shift, right? I mean, we somehow need to consider the fact that we have, each row is in a separate list, so there are chunks. So what can we do instead? Well, we can employ the same binary search technique, but instead use a 2 times binary search technique. So the first binary search will find the row, and the next one will find the column. So let's look at an example, right? Let's say example 3, we will find the midpoint, and we'll say in the midpoint we have a range, right? We have a range from 10 to 20. Is our target of 3 within that range? If it was, then we would actually, let's just say no. So it's not. So what do we do? Well, then we say, let's look at the biggest element, 20. Is our target less than or greater than this? Well, it's less than this, right? So what can we do instead? Well, we can look at, and actually we can choose, either the first element or the last element. I'm just choosing the last element, but we can basically say, okay, so it's not going to be in any of these rows. We can look at the last row, the first row, or the row remaining, and say, okay, it's got to be here, right? It's in the range between 7 and 1. So that checks out. The first binary search checks out. Then we do binary search again on our target row. We've got 1, 3, 5, and 7. We'll look for 3. 3 exists, therefore we return true. If 3 didn't, we would just return false. So we'll basically, again, using 2 binary search, a double binary search solution, right? We're running binary search twice. So binary search to find the row, and then binary search to find the individual column as well. So I hope that makes sense, guys. Let's get to coding, and if it doesn't make sense now, it'll definitely make sense when we get to coding the solution up. So the first thing we want to do, right, is, we're going to be running binary search twice. So instead of rewriting binary search, we want to, as best practice, abstract that logic away into a separate function. So we're going to create a binary search function with an array and a target, and we'll have left and right pointers 0, and then length of the array minus 1. Okay, and we'll say while left is less than or equal to right, mid is going to be equal to left plus right divided by 2. Okay, so if the target is equal to array mid, well, in that case, we can just simply return true, right? We found our target. Otherwise, if our target is greater than array mid, well, then what do we want to do? Well, we want to shift our left pointer. We want to set our left pointer to equal to mid plus 1, else right pointer is going to be equal to mid minus 1. We then want to look on, the left-hand side. So, yeah, if this while loop doesn't pass, then we're just going to return false. And now that we've got our binary search function written, we can now go into do binary search on the matrix itself, so on the binary search for the rows. So we're just going to say, let's say j and k 0, and then the length of the matrix minus 1. And now what we want to say is, while j is less than or equal to k, so it's the same logic basically. While, and actually, I think I can just copy, actually no, I won't. So we'll just say j is less than or equal to k, and then again we want to have a midpoint, so midpoint is going to be equal to j plus k, and again j plus k are at left and right. We're just using j and k because we've already used the left and right variables, so we can't reuse those names. Then for brevity's sake, we're going to get the length of the matrix, because we're going to need it, midpoint. And the next thing we can do is say, is our target within this range, right? Is it within the range? Is it greater than or equal to matrix mid 0? And is it less than or equal to matrix mid n minus 1? Okay, if it's within this range, then we can just do binary search on this row, right? We can just do return binary search. We can pass in matrix mid, and then we can also pass in target. Okay, so that's that. If we let me just say target. Okay, cool. The next thing we can do is say, if the row that we are at does not contain, if we know that we won't contain the mid, well then we want to look at which row should we go at next, right? Should we go to the row above or to the row below? Which row do we want to choose? Well, we can again say if target, like we discussed, if target is greater than the last value, actually let's just choose the first value. It doesn't matter if we choose the first or the last. Actually, let's just go for the last, just because it's easier to kind of visualize. We'll say j is going to be equal to mid plus 1, so if our target is greater, we want to look on the right hand side. Else we want to look, we'll say k is going to be equal to mid minus 1. And if this while loop, this initial binary search, this outer binary search does not return true, then we just want to return false. So let's submit our code and let's check that actually works. And it does. It passes all 133 test cases. So I hope this video made sense, guys. I hope the solution makes sense. Basically just a double binary search solution. I think there is another way by flattening the matrix using it's more arithmetic heavy though. This is I guess what I found to be the most intuitive. So in terms of time complexity for this problem, well, it does satisfy this time complexity. I'll just write it down. So that's going to be, big O of log m by n, and space is going to be big O of 1. So with that being said, guys, I hope you enjoyed this video, and I'll catch you in the next one.